All right, so today we are doing the day 3 notes. We're actually doing sections 1.4 and 1.5 if you happen to be following along in your textbooks, or they are labeled that way in your notes as well. These two sections go hand in hand. They're almost identical. The only difference is in the first section, we talk about expressions. Expressions don't have equal signs. And the second half of today, we're going to talk about equations. Equations do have equal signs, but everything else is pretty much the same. So here's example 1. It says to identify the variable when necessary. We're going to do that using a let statement. And we're going to write an algebraic expression. Here is part A. Now in your notes, it says blank times a number. You have to fill in that part. So the questions aren't already done for you. You kind of have to follow along, fill in the question, and answer it with me. We are going to start all of these where we see the phrase a number by defining a variable. So we are going to start by saying a let statement. Let whatever variable you want to use equal the unknown. The unknown in this case is just a number. So I am going to let n equal a number. Now, I'm just going to rewrite this using math symbols, and instead of the words a number, I'm going to use the variable that I just picked. So 12 times a number would be written as 12n. And remember, a number right next to a letter, we call this the coefficient. We call this the variable. That means multiplication. Any questions so far? All right, here's part B. A number decreased by 17. A number decreased by 17. So same setup. We don't know what the number is. A number. Anytime we don't know something in algebra class, we use a variable. So I'm going to start with a let statement. Let n equal number. And then I'm just going to change this from words to math symbols, taking out a number and replacing it with the variable that I just picked. Does anyone know what decreased by means? Subtract. So n minus 17. What are your questions? Part C says 4/5 of a number. So again, we have a number. I need to define a variable using a let statement. I'm going to let n equal that number. Of is kind of like a hidden math word. Does anyone know it? Yes.
It means multiplication.
Yes. So we want 3/5 multiplied by n. Sorry, 4/5. I said 3/5. Now that's the way that 4/5 comes up when you type it. I would not write it like that. I would write it like this. It's just sort of the difference between computer-generated and handwritten notes. So I do apologize about that. Questions? All right. Part D, the quotient of 3 and a number. Once again, a number. So what do I write first? Yep, a let statement. Let. I always use n's. If you want to use like your first initial or something, go for it. But in this case, it equals the number. And then another mathy term, quotient. Oh, no. Yes. So we are going to do the quotient of 3 and a number. Once again, this is how it looks when you type it. When you write it, it should look more like this. Some people go old school division symbol. You are not going to see this much anymore. This is the more common way you're going to see it. This is, I don't even know why they still teach this, honestly, but
They should.
Who knows?
They teach it that way.
Well, it's kind of weird because, like, up to a certain age level, this is what you see it, and then all of a sudden it just turns over to that. So it's okay. They mean the same thing. This is just the way I do it. Questions? All right, and here's part E. This is where it gets a little tricky. You kind of have to pull this apart. All right, so first thing, the let statement. So we're going to let n equal the number. Now, I'm going to ask you something.
What?
If my husband has $10 and I said that I had $9 less than he did,
That means you had only $1.
I have only $1. Was that 9 minus 10 or 10 minus 9?
9 minus 10 because it. Wait.
Yeah, you have to start with the number and take 9 away from it. That's the trick with the words less than.
Yeah.
You start with the number part and then you take away the 9 or whatever number came right before the less than. Anytime you're stuck, take the words the number out and replace it with a really easy number like 10 or 20 or something like that. Okay? The other trick in this one is the word double. Times 2. Good. So I want 2 times a number, so 2n. Then I'm going to take the 9 away. The sum of 12 and twice a number. I already have the first step up there, the let statement, let n equal a number. Sum means add. So we're going to add 12 and 2n. Good. Now, the cool thing about addition is that order doesn't matter. If you put 2n plus 12, that's the same thing as 12 plus 2n. So subtraction and division, you kind of have to stress like a little bitty bit about the order. Addition and multiplication, it's fine either way. There are many correct answers here. I am open to suggestions. Yes.
Twice the number decreased by 6.
Very good. Twice a number. Decreased by 6. The fancy way would say 6 less than twice a number, or 6 less than double a number, or 6 less than 2 times a number, or twice a number minus 6. All acceptable answers. Anyone want to double check their answer? Are we good to go? We good? Once again, there is a pre-made answer that's going to pop up, but before that, let's take some suggestions. Yes.
The sum of 2 and 3 times a number.
You got it backwards. The sum
of 2, I said that.
The sum of 2,
And
let's say a number and 2. How about that? Since that's the way it's written. The sum of a number and 2. Then what do they do with this sum? Multiplied by 3. Good.
I don't like this.
The common way to handle parentheses is to use the statement, the quantity. So the way this is written is correct, because this tells us to do the sum first and then multiply by 3. Perfect. Okay? Another way to do it so that you know that the parentheses should be there is to say 3 times the quantity, and then x plus 2, or x, the sum of x and 2. But those words, the quantity, means use parentheses. So if you see those, great. If you can do it without, great. This is perfect. Any questions? So part C is another one where there are just so many ways to say it. A common one would be to use that fancy word quotient, or just like this, a number divided by 3 and then minus 7. I'm not sure why I wrote 3 and then I wrote out the number 7. There's no significance there. That's just what it did, so I am sorry. All right, here's D. Yep.
3 minus a number to the second power.
Works for me. I'll write it out in words. 3
I don't like that.
minus or subtract or decrease by. Did you say a number squared?
Yes.
Very good. Or you could even say like a number times itself, or something like that. But yes, multiple ways that it works. Again, I'm taking the first suggestion, and that's what we're all writing down. All right. The last example for the expression side of the notes is up on the board. We want to find the area and the perimeter. Let's do area first. The formula for area of a rectangle is this. Area equals length times width. In this problem, the length is 15 centimeters. So I'll take the L out and put 15 in. And then the width is W, so that pretty much stays the same. And then you can actually multiply it out. Since we don't know the width, we're going to keep it W. It's just 15W. And then anytime we're talking about area, our label is the unit squared. It just means you multiply 2 centimeters, centimeter squared. You say square centimeters when you talk about it in real life. Hmm?
Our thing on ours says more like centimeters.
Oh, I see. You can add the centimeters. Be a little more exact. Thank you for pointing that out. All right, next we'll talk about perimeter. A lot of people just think of perimeter as adding all the sides. That's actually perfect. But when you add the sides together, 2 of them are always the same. So 2 of the length. And then the other 2, the widths, are always the same. So you could say length plus width. Or the simple way is 2 times the length plus 2 times the width. And then again, we know those values, or at least we know the length part. So take the word length out or the L out, put the 15 in, and then width is going to just stay W. You can actually do the math there. The 2 times the 15 gives you 30. And then just keep the 2W part 2W. Perimeter is a length, so you don't do anything with the units. Just keep it centimeters. And that's 1.4 out of your book. The expressions. Any questions? All right, so when we get into solving equations, we'll look at a lot more problems like this, like real life problems. So we're going to practice how these are going to look. So A says, Tara is 4 inches taller than Sean. If Sean is S inches tall, then Tara's height is blank inches. So to do something like this, we're going to set up these rectangles just to keep ourselves organized. We're going to call Sean something. We're going to call Tara something. And we're going to write those expressions inside these rectangles. They told us what they want us to call Sean. What is it? S. And how does Tara's height relate to Sean's height?
It's 3 inches taller.
What operation would that be?
Oh, plus 3.
Yeah, so we would call Tara's height S plus 3. So if Sean is S, Tara is just S plus 3. So in this one, we are talking about two ladies and how much money they have, and they tell us that Chrissy is going to be C dollars. The amount of money Chrissy has is C. So again, we're going to just set up a little workspace for ourselves. And Chrissy, we already know. C. And how does Kristen relate to C? Kristen's amount is twice as much. What does twice as much mean? Times
A number.
2. So 2C. What are your questions? All right. Here's the next one. This one we're actually going to do twice. We're going to put them both in terms of K, and then we're going to put them both in terms of L. So this says Mrs. Carr is 34 years older than Luke. So real quick, who's older? Mrs. Carr. Okay, so Mrs. Carr is K. And then we want to write an expression for Luke. So if we start with K for Carr, how would Luke's age relate to K?
Minus 34.
Very good. K minus 34. Now I want to go in reverse. So I want to start with Luke. So I'll call Luke L. And then if you know his age, what would you do to it to find her age?
Plus 34.
Yeah. Good. Does that make sense? We're kind of doing it and then doing it backwards. In terms of K and in terms of L. This is one of those where if you're stuck, think of an actual number. Like, let's say Luke is 10. She'd be 44, right? Double check if that works, okay? If you put a 44 in here and a 44 here, would you still end up with Luke being 10? You would. So that's kind of, I like to pause, double check. One more of this type, D. Lauren has $15 more than Tori. If Tori has T dollars, Lauren has blank. And then we're going to do it in reverse. If Lauren has blank, Tori has, if Lauren has L, Tori has blank. What? What did I say? Whatever, Lauren. You know how many names I'm trying to memorize right now? Shall be happy I know your name. All right. So let's do in terms of T first. So if Tori is T, then Laura is... Yeah, Laura has more, right? So if we start at Tori, we got to add. So that's in terms of T. We want T to be the variable. We can do the same process, but we can start at Laura.
It would be L, and then when we subtract it.
Then we'd have to subtract because Tori has less than she does. I always go back to who has more. Or who's older. Or who, whatever the problem is. Which number should be greater, you can usually tell that right away. And then that'll help you decide if you're adding or subtracting. Or multiplying or dividing. Questions? So here's where the equations actually start. My bad from a minute ago. This is section 1.5. It goes pretty quickly because all of the words are the same, except there's a new word. And it's is or is equal to. That is like where the balance is in your sentence. I always find the is, or in this case, the is equal to. That's the equal sign. What's going to come after that? 5. Easy. The first part looks like it's going to take a little bit more work. So I'm going to start out by saying what I'm going to let a number be. Twice a number. Twice a number. So 2n increased by the square of y. So we have two variables here. One of them we had to define because it just said a number. The other one, they told us what to make the variable. This is one where I'd probably say, like, pause, review, twice a number works. Increased by works. The square of y works is equal to 5. Done. Number 2, the square of the product of 2 and a number, here's my breaking point, is equal to 22. I don't know. I just like to do the easy side first. Boom. Halfway done. The square. So I'm going to square something. And what am I squaring? 2 times n. Now, if I leave it this way, I'm just squaring the n part. But I want to actually square the product of 2 and a number, so I need parentheses to show that that part has to happen first. And then I left something out. Since they didn't tell me what number to use, I have to actually define that number with a let statement. So do you see how now we have a variable, but it's already been defined for us? So you don't have to say let t equal t. They already gave us that part, okay? So the square of t increased by 17 is 32. Great. The square of t. How would that look?
T2.
Increased by is 32. Done. So is equal to the cube of a number. Oh, darn. We need to let n equal number. Since there is the variable s, but there's another one that we have to set up first. Cube of a number.
What would be n3?
N to the third?
Yeah.
Yeah. Decreased by 18. Good. Questions? All right, so we're going to skip a couple just so we can get through these notes before class ends. Number 8, so down at the bottom of the page, you have a triangle. It says write an equation involving x if the perimeter of the triangle is 14. How do you find perimeter?
You add those sides together.
Add all the sides. So I'm going to just write it out, adding all the sides. I know it equals 14. If you want to rewrite it the other way, the 3 plus 6 plus x then equals 14, that's fine. It's the same thing. Now we have like terms here, so you can go ahead and add them. 3 plus 6 is 9, and that equals x. Or again, if you want to write it x plus 9 equals 14, that is more than acceptable as well. Okay, what did we learn today?
What's this thing called?
Summary?
Nah, what we learned today? What's it called?
I learned how to write, what are the two things we wrote? Equations.
And the other
Starts with an E. Expressions. Good. All right, and then I'm going to let you roll with the next two. So write any questions that you still have for me, and then you can write a sample question that you might see on the test. Remember, the sample question you can just rewrite one of the ones we did. You could pick one of the ones we skipped and fill in the blanks, use your imagination. You could take one from your homework you want. Okay? All good options. But I want you to write what you're still confused about, if anything. If not, you can write, I understand this lesson. That's just fine. And then write me a sample question that you can go back later and use to study.